My name is Bill Fabian, Vice President of Monroe Infrared Technology. And as I just stated, next month will be 36 years since I started doing infrared. We're headquartered in Brunswick, Maine. In the last 2.5 years, we've grown from 11 people to 26 people. We've really expanded our inspection services and our training division, and finally getting some people doing some training under me. Still not the CRT class. I'm still doing that all myself, but I live in Shelby Township, Michigan. Don't hold that against me, but I enjoy infrared and I enjoy helping the home inspectors. So you see my phone number here, both cell number and corporate number, and I've also added my R800 number to my signature line on my camera feed. So anytime you want to write that down. Okay, of course. Come on. Got Monroe Infrared, it was only a FLIR dealer and distributor. We now offer the Hike Micro infrared cameras, which is a great alternative to FLIR. Their EX models, the E6, E8, which everybody has, are still available. And I don't want to turn this training class into a sales pitch, but I think it would be a mistake not to mention that November 21st is Cyber Week or Black Friday week or whatever you want to call it. The FLIR is offering the E8, the E6, the C5, and C3X, I think at 20% off. And Hike Micro is also offering the M30 and M10. They have a very nice competitive product. But anyway, infrared cameras, we sell thermal drones, and we, like a lot of, or unlike a lot of the others, our after sales support is unmatched in the industry. When you need help in applications, sending image, what the heck am I looking at? You can send us images, send me an image. That 800 or that cell phone number was, direct to me, and I can help you out at any time. We offer all levels of training, level 1, level 2, level 3. We have a 2-day, obviously the CRT class, but then roofing, electrical, energy, and also some custom design classes. I'm going to get right into the applications. And as I said a couple minutes ago, the applications have expanded. And the reason for a lot of our updates to the manual are feedback from home inspectors. But to go through these 8 images, electrical, high volt, your incoming feed in the upper left-hand corner, showing the hot connection to the house. Top middle is a bee hive that was found behind the fascia board, and then they removed the fascia. You'll see some images on those as well. Measuring water temperatures in the upper right. Missing insulation, middle left, the grayscale image. The very middle image is a heat pump that would not turn on, so the home inspector just used the thermal image to show, hey, there's no heat. It won't turn on, it won't run. Without a doubt, the number 1 application of infrared for home inspectors is finding hidden water or moisture. Middle row, far right, you're looking at some water intrusion into a porous stone fireplace. That's in the hearth. And lower left is some water in a ceiling in a garage where the roof was leaking, but absolutely no visual sign. Bottom right is a really wild one. A home inspector here in the Detroit area actually took him 3 visits to the house to figure out what the heck was going on. It's become more popular as we go on, but this is from about 7 years ago. The vinyl siding on the north side of the house was melting, and it ended up being the sun reflecting off the next door neighbor's windows. And because of argon depletion, which I can get into, but they insulate double pane windows with argon gas. And before the seal breaks, the argon gas will leave that space between the two panes of glass through an opening at the seal so small that the atmosphere can't get in. And it puts that space between the two panes of glass under a vacuum, and it's trying to pull the glass together. Well, when you put a low E coating on that glass, and a low E stands for low emissivity and high reflectivity, and you got that curved, or basically a parabolic mirror, that piece of glass, instead of the reflection being square because it's concave, the reflection takes all that sun's energy and focuses it on a very small spot. So you see those two small hot spots on that vinyl siding, and he measured 198-degree vinyl temperature in the shade. So yeah, there was a nice curved path, the path of the sun as it moved through the sky across the melted siding. Some really cool applications. I'm not going to get into, I mean, we already covered all this stuff. There's the current cameras, the EX models, the C5, and then the higher end E54, 76, 86, and 96. Here's the Hike Micro, the M30, M10, and Pocket 2. They almost look the same as the FLIR counterparts, but you can get much higher resolution and a better warranty. So if you're interested in cameras, give me a call sometime after class. But so for those of you that have not ever attended the CRT class or gone to level 1 or level 2, what benefit does infrared have for a home inspector? Why should a home inspector even use an infrared camera? And that's because you're doing a more thorough inspection. I'm going to show you some examples coming up. You're not going to find that water in the carpet or that water in the ceiling unless there's a stain. And I had a home inspector during class say, yeah, but it's not our job to find hidden problems. While that may be true, if you don't see it because you don't use infrared, and then your client ends up buying that house, and 2 months later, 3 months later, decides to replace that carpeting, and they find a wet subfloor, you know who they're going to call. They're going to want to know why you didn't find it when you did the home inspection. So I'll show you some of this stuff. Anyway, I had another guy stand up in class, and I'm not going to do that infrared. It's going to open me up to more liability. Well, the fact of the matter is, and this comes from your insurance companies, Inspector Pro. I can't think of the other one. But anyway, the fact is that home inspectors that have a good infrared camera are qualified and certified to do these inspections, are doing a much more thorough inspection, and they're finding those things, and water being number one, that come back to bite you in the butt later. So your insurance companies, excuse me, love the fact that home inspectors are starting to use infrared because you are finding those things. But I warn everybody right now, I sell infrared cameras, but if you're going to buy an infrared camera and not go to training, whether it's from me or ITC or whoever it's from, don't waste your money on an infrared camera because operating an infrared camera, I think the worst thing you can call it is a camera, because it's not just about taking a picture. You have to understand the camera's capabilities and limitations. And once you do, you can do some great work, but they're not magic. While they are magical, they're not magic. And the problem is your clients think it is magic. They think it can see through the walls. Their exposure to infrared is what they've seen in the movies with Predator years ago. And then recently Hobbs and Shaw with Dwayne The Rock Johnson and Jason Statham. They're holding an infrared camera up against a red steel door, and the movie camera comes in, looks at the LCD screen, and shows people on the other side of the door. So the public's perception is that infrared cameras can see through that door, can see through the wall. And that's why you need to learn the limitations and learn to work within its capabilities. If you don't, then you can misinterpret, and you can make mistakes calling things out that aren't true. If you haven't heard the horror stories, they're out there, where a home inspector called out, everything behind the drywall is wet. So they tear down the drywall and it's perfectly dry. Another one, everything under the vinyl flooring is wet. All the subfloor is wet. They hire a contractor, comes in, tears up the vinyl flooring, and the subfloor is perfectly dry. Because that home inspector, using an infrared camera, didn't understand that an infrared camera doesn't say it's not wet. An infrared camera shows you thermal differences, and that's all it shows you. You've got to use the other forms of or tools to help you figure out what it's causing. So that's why I want to turn this next 45 minutes into more training than sales pitch. So, don't hesitate to ask questions. Turn your microphones on, ask away. I'm all ears. And anyway, and across the country, home inspectors that use a good infrared camera are able to charge more for it. And if they don't, I think they're missing out. But whether you do or you don't, whether you use it as an ancillary service, and offer it up as an add-on, or you make the decision to use infrared on every home inspection from this day forward, I think you're worth more money. And that's, with that knowledge, you can do that. As I've just said, the number one application is finding moisture, finding water due to plumbing roofs, plumbing leaks, roof leaks, window leaks, pet leaks. I mean, there's so much you can do with infrared. Locating missing insulation or non-performing insulation. While I don't teach you how to be a full-blown energy auditor, we go through how to interpret the walls and the ceilings and the rim joists as to, does it appear to be properly insulated or not? From a safety perspective or aspect, finding hot electrical circuits. I hope I have it in this presentation, but a home inspector found the absolute hottest electrical connection, hotter than anything I've ever found in my career in doing commercial and, industrial, a dryer connection in the breaker or on the side of the breaker from an electric dryer running at 1,452 degrees Fahrenheit. The connection was glowing cherry red. So yes, while you take the dead front off or the cover off, you didn't need an infrared camera to find it. But it's not a matter of if, it's a matter of when you save someone's life using infrared by inspecting the electrical system. This is why Hartford Steam Boiler Insurance Company and FM Global mandate that their commercial and industrial clients have infrared done on their electrical systems every year, every other year, or every third year, depending on what kind of facility it is. So in order for them to be a client of those insurance companies, they have to do the infrared periodically. Everybody's heard of the condo that collapsed, that condo building that collapsed in Florida. And now they're requiring infrared be done on the electrical system and structural analysis, infrared on insulation, as well as water infiltration. Water is the single most destructive force in a building. Pest infestation from ants, termites, bees, raccoons. I mean, there are so many applications. Radiant heating systems, appliances, air coming into the house called air infiltration, argon depletion, as we already talked about, and so much more. So get into some basics on infrared so that you're not, if you haven't been to the training, you can, at least know a little bit more by the time we log off here in 45 minutes. Infrared cameras cannot see through glass. They cannot see through water. Visually, we can see through glass or we can see through water. But the infrared wavelengths that these cameras operate in, that piece of glass in that building might as well be a 1/4-inch thick piece of plywood. You cannot see through glass with the long wave infrared cameras. That's why we can look at windows and see when they have that argon depletion. And while infrared cameras work great to go deer hunting, and I'm leaving Friday to go up to the Upper Peninsula of Michigan, and I take thermal imaging out in the woods with me to see what's out there. They don't work with a darn to go fishing, because you can be sitting in your boat and look out over the edge of the boat and see the fish with your eyes, but the infrared camera cannot see into the water. It only sees surface temperature of the water. So why I make that point is, if it's raining out and the outside of that house is wet, it do you absolutely no good to look at that house from the outside. Visually, you can see the house through the water, but with the infrared camera, when you pick up that infrared camera and look at it, all you're going to see is the water running down the outside of the house. We're going to get into how heat energy moves. Always, always, always from hot to cold or warmer to cooler. Investigating a house from the inside can be very different than looking at that same house from the outside. And then you have different types of construction all over the country. Up in the Northeast, you guys got 300-year-old brick homes, 2x4s, 2x6, crawl spaces, basements, slab on grade. I mean, there's 100-year-old balloon framing. There's all kinds of construction. So understanding what kind of construction you're looking at will tell you what to expect in that thermal image when you pick up your infrared camera. Like 2x4s on 16-inch centers. When you get to the corners, there's a lot more 2x4 in that corner. So it's normal to see the corners colder or in the wintertime or warmer in the summertime. Infrared is not just about taking a picture. Whether you're taking temperature readings or you're just finding the thermal anomaly, you have to understand emissivity and reflectivity. Emissivity is the single most important and at the same time confusing concept to get your head wrapped around. It's the ability of a material to emit or radiate heat energy. Shiny metals have extremely low emissivity. That's why I tell guys all the time, don't even think of looking at ductwork or a shiny bus bar, because it's a thermal mirror. When you look at that with your infrared camera, the only heat you're seeing is the heat energy reflecting off of that shiny metal. I had a home inspector post on my social media site a thermal image. He's looking into an electric panel and he goes, "Why do I have a hot spot in the bus bar away from any of the lug connections?" And I looked at it and I said, "That's your head. That's your head reflecting off that bus bar." So you've got to understand emissivity and reflectivity. And most importantly, number 3 on this page, learn how to speak intelligently about what the infrared camera is showing you. Don't overspeak what the infrared camera is showing you. An infrared camera doesn't say it's wet. An infrared camera doesn't say a wall cavity is uninsulated. An infrared camera doesn't say that's a raccoon on the other side of the wall. An infrared camera doesn't say that breaker's overloaded. You've got to learn the limitations. So in 36 years, I've never heard an infrared camera say anything, okay? It's the operator standing behind the camera that opens up his trap, misinterprets what he's looking at, that gets him in trouble. And that's why training is so important. I know I'm beating that one to death, but check this video out. I'm looking at this big thermal image that you see right here is a 480 volt electric panel, 3 phases. A phase on the left, B phase in the middle, and C phase on the right. B phase, that center phase, looks warmer. I'm standing right in front of it. That's actually my body heat reflecting off of B phase. Watch as if this works right. Come on. There it goes. Watch as I move left and right. That shiny metal, that's my body heat reflecting off that shiny metal. So another helpful hint, if you think you found a thermal anomaly, a thermal difference, so you think you got a problem, look at it from another angle. If it moves or goes away, you can ignore it because it's probably just a reflection. If you look at it from two different angles and it stays there, it looks the same from two different positions, now it's a true thermal anomaly that you need to investigate further. Why do we find water inside a house? Because of the evaporative cooling effect. How long is it going to show up? As long as it's wet. The number one condition needed to find water in the house is it must be wet at the time of the inspection. Well, of course, right? Well, no, not of course. You've got those clients who think infrared cameras are magic. And this is a true, I got this phone call. It's October a few years ago. And this homeowner called me and said, hey, we had water come into the house this past April. So this summer we put a new roof on the house. It's now October. Can you come in now and tell me what got wet last April? Not if it's not wet today. So just like a home inspection is a snapshot in time, and it's a visual, non-invasive, non-destructive evaluation of the components found the day of the inspection, that's exactly what infrared is. Infrared can't tell the future or the past. It is when you go do your inspection, what are the conditions that you found that day? And everything we do with an infrared camera is condition-based, means you have to have the right conditions. In order to do water, it's got to be wet. And indoors, you have to have relative humidity below about 75%. That ensures that the water is evaporating. And as the water evaporates, it causes the evaporative cooling effect. And that's why the thermal anomaly on water shows up cooler than the surroundings. Electrical, you got to have load on the electrical system. Anyway, I can go on and on. Every application of infrared or with an infrared camera, you have to have the right conditions or you can't do the inspection. Here's a great thermal visual picture. And this is actually Bob Pearson, if you may know him. He used to be with Allen Insurance. He's now with Inspector Pro. Bob's been using these two images from me for a long, long time, 8 years, 7, 8 years, whatever it is. Somebody goes to sell their house, you guys know it. They typically will stage the house. They clean it up, they vacuum it up, they paint it up. They're trying to cover up the problems. You come into this bedroom, and yes, there's an outlet in the corner. And maybe when you get down on one knee to plug in your outlet tester, and then you stand up and you go, my darn knee's wet. Maybe then you would have found the water in the carpet that you otherwise cannot see visually. So that is really right there. That speaks volumes for what you guys do as home inspectors. What this ended up being was, again, this wall on the left, that is the common wall between the bedroom and bathroom. And there was a sink on the other side of this wall. And so you same air temperature in the bedroom as in the bathroom. So there should be no thermal difference in this wall. But if you look over here in the thermal image, there is. And that was the drain line leaking within the wall. Came down to the bottom plate, came under the wall. And when they had boxes and stuff stacked up in that corner, it kept it wet. It reduced any evaporative, or evaporation until they picked the boxes up. And they probably picked up these wet boxes. Oh my gosh, it's wet. What, vacuum it up. Oh, they'll never know. Well, yeah, they will. If you use an infrared, that's right there. Why infrared is so valuable for a home inspection, because you're finding the things that can come back to bite you later. Or worse, what if they, they pick up a wet box and they just say, well, we'll move that dresser onto that wall now and cover it up. They wouldn't do that. Yeah, they will. Yeah, I've seen kids swimming pools in the attics collecting rainwater and coolers. And anyway, I don't want to spin off too far. But all home inspectors today are probably using moisture meters. But you're not sliding it over every square inch of the wall and the ceiling and the floors. You're putting it on stains, maybe at bottom corners of windows, around the toilets. But this one right here on your screen right now, that thermal anomaly in that corner of that room, this is less than a 2-year-old house. And I'm telling you guys, without an infrared camera, you would not have found this, because there's no wrinkle in the paint. There's no stain. It's not under the window. It's a ranch. You can see it's starting up at the top of the wall. It ended up being ice damming in the wintertime. Water backed up under the shingles, came down into that outside wall, and we found it with the infrared. So the infrared camera, as soon as I found this, when I'm doing a little training with some guys, I wanted to yell out, holy cow, look at that. I didn't say anything. I walked over there, and with my moisture meter, I took a reading next to the thermal anomaly. And then I put the moisture meter on it and compared the reading on the thermal, and it pegged my moisture meter. It was wet. Now I can say it's wet. This is an air conditioner, actually up in your neck of the woods, up in the East Coast. It's a commercial building. And actually, the conditions needed to find water in a house are identical to the conditions needed to find water in a commercial building. There's no reason at all you can't, once you understand how to do it, that you can't market this service to commercial, industrial, whatever you want. There's no government regulations that say if you buy an infrared camera, you have to go get any training at all. And that's a problem I see with our industry. It's like becoming a home inspector without learning how to do home inspections. You'll do some, but you're not going to stay in business very long. And that's the same thing with infrared. You start calling out things that aren't true, and word's going to spread quick. So anyway, this is an air conditioner. It's got a fan in it, and it pulls air in at the base of the floor. And the inspector doing this, he said, when I walked into this end of the building, you could just smell the mildew in the air. So the air conditioner draws air in at the bottom, moves it across a coil inside the air conditioner, and exits the air conditioned air out the top. And when you move that air across that coil, condensation forms, and there's a condensation collection pan in there with a drain line. Well, the drain line had plugged up. So the condensate pan filled up and spilled out onto the floor. Visually, you can't see that water. But here in the thermal image, you can see that water in the carpet. Now, look at the pattern difference between the water in the carpet and the thermal differences across the surface of that air conditioner. Where the air conditioner is drawing air in at the bottom and then exiting the cold air out top, it's a lot colder at the top than it is at the bottom. So there's a gradual change in temperature from bottom to top. There's no edge pattern. This is indicative of water and energy issues. Now look at the pattern in the carpet. Water, usually in horizontal surfaces, both ceilings and floors, gives you that sharp edge pattern like you see here. There's no gradual change from cold to warm. It's just that real defined edge where one side of it's wet, one side of it's dry. But an infrared camera doesn't say that's water. You see it with the infrared camera. You need to walk over there with a moisture meter and confirm the thermal anomaly is actually water. Just because you test it once, and yes, it's water, doesn't mean every time. So you got to continually confirm your thermal anomaly with the other tools that you guys are carrying. Here in a vertical wall, homeowner knew they had water coming in. You can see that thermal anomaly. They wanted to know where it was coming from. You can see that thermal anomaly in the wall. It wasn't the window. That's where it showed up on the inside of the house. But look at the visual picture and look at the ceiling. There's a repair directly above the trash can and a stain right here and another stain over here by the window. It ended up being a plugged up, it had shrubs and trees growing out of the gutter. And when it rained, water overflowed the gutter at that point. What they didn't know is the left side of that window also had water in it. But it doesn't matter that I've been doing infrared this many years. I can't look at that image and tell you that's water or that's air or that's missing insulation. You've got to use those tools to confirm or help you figure out what's going on. Thermal capacitance is the ability of a material to store thermal energy. Water has very high thermal capacitance. So when you get water hot, you pour a hot cup of coffee, it stays hot for a good, at least warm for a long time. That's the driving mechanism behind finding water in stucco, eaves, flat roofs for moisture detection underneath the membrane in the insulation. Here's a big 7-story condo complex, and with the infrared, we can find the water intrusion into the stucco. Here's some eaves. Same thing, no kick-out flashing on that gutter on the top two, left and right, and then water intrusion at the window on the bottom, left and right. But again, I can't stress it. An infrared camera doesn't say it's wet. You've got to use a moisture meter. Missing insulation in the walls and ceilings. Energy audits, some guys do that full time. But my job is and my goal during the CRT class is to give you all the conditions, what things should look like, what they shouldn't look like, so that you can, maybe you refer them, hey, this, you got some serious problems, you probably want to have, or it appears you have some serious issues, you might want to have an energy audit done. The number one requirement to do energy diagnostics is you must have a temperature difference between inside the building and outside. There are ASTM standards written, which stands for the American Society for Test and Measurement, that say today you must have at least an 18-degree temperature difference from inside to out. Well, that's not air to air temperature. That's the paint surface or the inside surface to the outside surface. That ensures you've got heat energy moving from the hot side to the cold side. But that 18 degrees covers all cameras, even the low cost, plug in your iPhone type cameras, which I don't recommend. But if you've got a good infrared camera, you don't need nearly 20 degrees. You can do it with 8 or 9 degrees. And again, different anomalies can appear as different image patterns. It does take time to figure out what the camera's showing you, and beating the dead horse, but without training, you'll make mistakes. Here's a 100-year-old balloon framed house. The 2x4s show up warmer. The 2x4s or framing members show up warmer. The cavities show up colder. Does that mean it's insulated or uninsulated? Well, it depends what side of the wall you're looking at. It happens to be like 45 degrees, heavily cloudy day. So we're looking at this wall from the cold side. This indicates that this wall cavity is properly insulated, and the 2x4 is losing more energy because it has a lower R value than the insulation. So it's moving the heat from inside out faster than the insulation is. So this is what all the cavities should look like. Cold cavity, warm 2x4. This is what it looks like when they miss, or you get separation or cross bracing, or there's all kinds of stuff. You'll also notice no rim joists, no band joists, whatever you want to call it. This is balloon framing, 16-foot tall 2x4s. You see that dormers in the attic. Here's the other side of that same house. You can see settling in the cellulose that they put in the walls, missed cavities between the windows, first and second floor, and then on either side. The soffit vents look like they're on fire because when I went up into the attic, they didn't insulate the attic floor at all. Wide open interior walls to the attic. So all the heat they're adding to this house is just pouring up into the attic and flowing out, and that's why the soffit vents look like they're on fire. This young couple hired me, wanted to know, what can we do to make this house more energy efficient? I said, first thing I'd do is tear up all these boards and insulate this attic. No, we're just going to replace the windows and doors. You're creating more problems than fixing anything. But anyway. No, that's not a scope on a rifle. I want one, but no, that's the home inspector using an infrared camera. Now this is summertime and hot attic. That deer head is hanging on a wall. Behind that wall is an attic space there's no access to. And he said, he sent me the image. He said, do you think that wall is insulated at all? And I said, I don't think it's insulated at all. It's not that some of the cavities look good and some don't. They all look hot. They all look bad. So this is where the value of infrared. Our friends just moved up here from Jackson, Mississippi, and had me come and do an inspection on a house for them. And I told him, I said, Larry, you better put about $2,500 into into a rainy day fund, because all this insulation is going to need to be redone. It was bad. They walked away from the house. This is the kind of stuff you'll see. Uninsulated cavities where the 2x4s now from the inside look warmer and the cavity looks colder. That's not what you want to see inside a warm house. That indicates that if there's any insulation in that cavity, it's not performing as it's designed to perform. About 34 years ago, I told a builder, I'm standing in a house and I checked the infrared camera and I looked at an outside wall on a brand new house. And I said, there's no insulation in that cavity. He said, really? Grabs his hammer, busted a hole in the wall and pulled the drywall off the wall. And my eyes got about the size of a softball. And my jaw probably hit the floor, because that wall was then showed it was insulated, but it had been insulated improperly. Instead of stapling the craft-based fiberglass to the 2x4, they stapled it to the inside edge, which created an airspace between the drywall and the insulation. And that one cavity was about a ½ inch short of touching the top plate. So the cold air was allowed to travel freely between the insulation and the drywall. And with the drywall in place, that cavity looked just like these did. It looked just like an uninsulated cavity. But I learned the hard way, and this is what I tell all the people in class: learn from my mistakes, because I've made plenty of them over the years. An infrared camera doesn't say that's uninsulated. Inside, all you know is if there's any insulation in those cavities, it's not performing as it's designed to perform. They replace the ceiling light with a ceiling fan, and they go pull the insulation back to reinforce the box and don't put the insulation back right all the time. This is a scary one. Brand new construction. The only insulation in the ceiling, this was in Dallas, Texas, but the only insulation in the ceiling was under a plywood deck in the attic. During construction, they put all the sticks together. They used fiberglass bats underneath, and they put a plywood deck in the attic, and they put the entire mechanical system in the attic. We don't do that in the north. And then they finished the house, drywall and cabinets and carpet and tile and everything. Well, the last step during construction is to then, once all the drywall's in place, bring back the insulation contractor to blow in cellulose or fiberglass probably, and they use the drywall to hold the insulation in place. They never called the insulation contractor back. And the entire house had no insulation in the attics, other than underneath this deck. Here we have a really old image, like 25 years old, but to give you some insight, I didn't do this inspection. I didn't take this image, but there's a way to tell by looking, and you can tell you're looking at this window, this wall from the inside, but am I looking at it and it's cooler inside and hot outside, or vice versa? You're on the warm side and it's cold outside. Those little black dots right here, 1, 2, 3, 4. Those are the nails holding the drywall onto the 2x4. 2x4s have an R value. Drywall has an R value. Insulation has an R value because they're insulators. Nails and screws are conductors. They move that heat energy faster than anything that wall's made out of. So if they show up, you're inside the house and those nails show up cold, then it's colder on the other side of the wall. If they show up hot, it's hotter on the other side of the wall. And it's not just air to air temperature. I've had test results, 70 degrees in the house, 45 degrees outside. But if you don't take into consideration the solar loading, the sun had heated up. John Snell did a study in Vermont in the wintertime, 20-degree air temperature. I'm talking winter coat, hat, boots, gloves, the whole 9 yards. 20-degree air, but the sun shining on the side of that house had that house heated up to 140 degrees on the outside. Even though it was 70 in and 20 out, the flow of energy was not from inside out because the sun had changed that outside wall to so hot. Now the flow of energy is from outside in, and these guys are misinterpreting that during training. So you get, again, plus the cold glass tells me the sun's not shining on that wall. I'm on the warm side. I'm in a warm house and it's cold outside. I'm on the warm side, properly performing insulation, which we're into that season right now. You guys are all, up in the north. You're in a warm house doing your inspection. It's cold outside. It's 8 o'clock in the morning. I'm on the warm side. Properly performing insulation should look just like this, warmer than the 2x4 or framing members. This is what an uninsulated wall would look like. The framing members are warmer than the cavity. I can't say there's no insulation there. I know I'm beating that one to death as well, but I'm just trying to help you guys out and, hopefully you don't misinterpret and get yourself in trouble. Air infiltration coming under a window. Here's missing insulation please work safe. And I threaten I promise everyone, whether I get a 1 hour session, a 2 hour session, 2-day training, a 4-day training, everybody hears the same story. Here's a word of advice, and it comes from experience. If you're looking through your camera, don't move your feet. Because if you're looking through your camera, you're not going to be watching where you're walking. In our industry, we have had guys walk off of roofs doing infrared inspections. We've had, not our company, but our industry has had guys back up into high voltage electrical panels and get killed because they didn't watch where they were walking. So one simple rule of thumb will save you a world of hurt. If you're looking through your camera, don't move your feet. If you need to move your feet, bring the camera down, watch where you're walking, plant your feet, and then bring the camera back up. Another safety note is this right here. I'm no ladder expert, but I've heard of the 3-point ladder rule. And that does not mean 3 on everything else and 1 on the ladder. So please work safe. But this is this contractor having to come back, drill more holes and dense pack those cavities that they didn't fill the first time. Air infiltration on the right, leaking ductwork on the left. Air infiltration around an entry door during the summertime using a blower door. Hot foundation, rim joists, leaking ductwork in a wall. I mean, there's all kinds of stuff, all kinds of problems with this house. I know it's mine. Infrared cameras don't say there isn't an installation. Only a destructive test using a borescope. Drill a hole, stick that fiber optic will confirm that it is empty. But unless you work for homes on homes, most of you aren't drilling holes into people's walls. So unless you've confirmed it, don't say it's empty. Appliances, water heaters. Notice a shiny copper pipe. It looks cold. It's not. It's just looks cold because that shiny copper is super reflective, has a low emissivity. Measure the water temperature. You notice this one says that water is 126 degrees. And even though I'm using a high-end infrared camera, I'm standing right next to the sink. If you have a C2 or a C3 from FLIR, and it's got that big reticle, that big circle, don't go to the stream, because if that stream of water doesn't fill the reticle, you're not getting the accurate temperature. So this is another word of advice. If you're using an infrared camera and you're doing temperature measurement, you got that little reticle. Now you see there's two crosshairs on this. That's the more expensive the camera is, that it gets right down to a crosshair. But those lower cost cameras, some of them, that like the C2, it had a circle. It was big. That means you've got to fill that area with your object. If it doesn't fill that circle, it's going to average the temperature of your object and the background. So make sure you get close enough so that the object you're attempting to measure is as big or bigger than that little reticle that you measure temperature with. Are the gas appliances fired up? Electrical, refrigerator temperatures. I'm telling you guys, radiant heating systems. On the left is inside a house, obviously, and on the right, a snow melt system. What else can a home inspector do with an infrared camera? Every quarter car wash, every car wash in general that you have in the north, when it comes weather like we're having today, I mean, here in Michigan, we had snow. Every one of those car washes has to have a radiant heating in every one of the bays and in the approach in and out, because you allow that concrete to fall below 32 degrees, and then you wash your truck on it. We call those skating rinks here in Michigan when you flood the frozen concrete. So they got to keep that concrete temperature above about 40 degrees so that the water can drain away. And they develop leaks, or they want to convert a quarter, manual bay to a drive-through bay, and they want to mount all that gear to the floor. You can see where the lines are. They can then know where they can or cannot drill into that concrete slab. So there's a lot of stuff you can do with infrared. And again, infrared cameras find safety issues. And there's been many times, and I'll show you, hopefully I'm showing you a couple. It's been a while since I looked at this PowerPoint, but you've got to have load on the electrical system, and it's got to be loaded for at least 15 minutes or longer. So I recommend, as you're going through the house, take your camera with you, your infrared camera, but as you go through the living room, then the dining room and the bedrooms and everywhere, turn on every damn light in the house. Every exhaust fan, ceiling fan, anything, dryer, anything and everything you can turn on. Then go to the kitchen. Turn everything on, the range top, the oven, exhaust fan, everything. Then go to the electric panel. Now you're going to be looking at that electrical panel under the best conditions you can put it in. But just because you don't find a thermal anomaly doesn't mean one doesn't exist. Because you guys are not carrying bags full of curling irons. If you've got a breaker feeding 6 outlets and there's nothing plugged into those 6 outlets, there's no load on that circuit. You could have a significant problem with that, one of those connections in that circuit, but without any load, you're not going to have any heat. So you got to have load on the electrical circuit. But if you measure a connection on a wire, a connection on a breaker, disconnect, whatever, and you measure 70 degrees hotter than the other connections, I suggest you call that out as critical. Do not walk away from it, because that's a safety issue. Wait till you see what there's things out there. This is an electrical panel in an occupied home. There's things running. There's no thermal anomaly to report with the infrared camera. You can see the scale on the right side goes from 50 to 75 degrees. Nothing hot in that panel. But just because you don't see one, here's another one. Here's that one I was just telling you about. That connection from that electric dryer is glowing cherry red, 1,452 degrees on the connection. He said the insulation was bubbling and there was smoke coming off the insulation. You want to hear the scary part? The owner said, yeah, knew something was wrong. Every time we use that electric dryer, it trips a breaker, and we got to reset the breaker multiple times before it'll stick. One of these times it's not going to trip, and it's going to cause an electric fire. So they're out there, and that is such a safety issue. And again, if the cold connections are at let's say 75 degrees, at 145 degrees, I'm calling that critical. So this thing's been critical for 1,300 degrees. I mean, it's that hot. Abnormal heating at the main lug. Here's another one. 527 degree main lug connection. Safety issue. Call it out. Don't walk away from it till the realtor knows, the owner of that house knows. I couldn't live with myself if I found this, didn't tell somebody, and then something happened before they got my report. You saw this one at the beginning of the presentation. Let's look at that connection a little bit closer. Ignore the temperatures. Just look at the thermal anomaly. It's where that connection is. It's hotter at the connection. And as you travel away from the hot connection down the wire, you see you don't have to go but a foot or so, and both wires are the same temperature, same color, so they're about the same temperature. Or you go the other way. You don't have to go but 6 or 8 inches, and you see the heat dissipating. That's called a thermal gradient. So it's showing the direction of heat flow from the hot spot into the cooler wire. Take those two arrows showing the direction of the heat flow and turn them around. That thermal gradient is pointing to the problem. The problem is right there up on the roof. Write it up every time. A connection is a connection that if it shows hot at the connection, I don't care if you measure a 2-degree rise. If you're not using an amp meter to measure load, you cannot use NETA standards, the International Electric Testing Association's prioritization table for minor, intermediate, serious, or critical. I had a 20 amp breaker with a 1 amp load, had a 2-degree hotspot at the connection. 2 degrees. It would have been very easy to walk away from. I put my amp meter on it, saw that it was drawing a 1 amp load. There's a calculation, and to use NETA standards, you have to reference that temperature rise to a 50% load factor. And as you raise the load, you raise the temperature, but it does not rise linearly. It rises exponentially. It went from 2-degree rise to a 54-degree rise with only an 8 amp load. That's a serious hotspot on that breaker. So anyway, you can see I'm pretty passionate about infrared. I love this stuff. I'm an infrared geek. I take an infrared camera on vacation with me. I take it hunting. I've always got one with me. Here's a hot pool pump motor. Insect and vermin. We're running out of time. We got less than 10 minutes. That's a bee's nest above a ceiling out on a porch. There's that one I showed you on the opening slide. There's with the fascia board in the upper left-hand corner. That's the fascia board in place. There's the hole where the bees were coming and going. There's the shape of the hive right through the fascia board, and there's the hole, about lower left image. Then they took the fascia board off. There's a visual of directly in the hive and the thermal of the hive. Bo Passon is a home inspector, ASHI member, Fabian member down in the Orlando area somewhere. Anyway, he saw that brown stain where the cable goes in. He's shaking his head because the hole's 3 times, 4 times the size of the cable, and there's no caulk. And as he's looking at it, going, I can't believe they didn't caulk it, a bee comes flying out of the hole. So he grabbed his infrared camera. There's the shape of the hive behind that 3/8 inch thick fake faux brick. So he's going to document it. Takes his E8, and he's going to squeeze the trigger and take the picture. And he caught a bee in midair. You can see on the left that warm spot right there. There's the melting siding. And the culprit was that second floor window next door. Look at the reflection of the gutter off the glass. Even though it's a straight gutter, the reflection is a curved reflection. Again, you take that piece of glass and you put that between those 2 pieces of glass under a vacuum, that concave piece of glass gives you a reflection that it's like finding the ants on a sidewalk when we were a kid with our magnifying glass. It takes that sun's energy and focuses all that energy on this little hot spot. The sun's energy is intense, 10,000 degrees Fahrenheit, and it will melt the vinyl siding. My pet is house trained, not. And I told you I'm an infrared geek. So everybody knows who Nathan Thornberry is. Well, he had one of his inspection super conferences at the Peabody Hotel in Memphis, Tennessee, and they have the walk of the ducks of these. Every morning they bring the ducks down from the roof and they walk them out of the elevator and through the crowd to the fountain in the lobby. And then at 5 o'clock, they take them back to the roof. Everybody makes a big deal out of it. And all the adults are drinking adult beverages and the kids are. I heard this was happening, so I grabbed my infrared camera. Here comes the ducks. Told you, I love this stuff. It's so much fun. You never know what you're going to find. For infrared camera sales or training programs, sign up for a CRT class. If you're on the fence about incorporating infrared, come and learn what the infrared camera can do and why it's so valuable. I guarantee you're going to get your money's worth. At $695 for an attending or $595 more than 30 days in advance. It's quite frankly, ITC has a 2-day home inspection class. It's $1195, $995 or $1195. It's a lot more expensive, and it's not nearly. I guarantee you, it's not nearly as good as our class. So,
Bill, I have a couple questions for you.
Please bring it on.
Do you have your event calendars on your website?
Yes, go to monroeinfrared.com, as you see there. Click on the training tab, go to CRT, that logo, you can see it right there, and scroll down on the page and you'll see the upcoming, there's a Zoom class next week. Well, no, there's a Zoom class today. Next week I'm off hunting. There's another Zoom class in December, attending at IW. I think the next 3 months are up there.
Okay. Next question is, of the guys who are using thermal imaging equipment to enhance their inspections, do you have a feel for how much average time it may be adding to their inspection, or are they just going through and scanning things, just looking for potential things to dig into, or just?
I just had a guy in my Tacoma class 2 weeks ago that said doesn't add any time to his inspection. It adds a little bit of time. The overall average that I've heard back from it, because I've asked that question, how how much time would you say it adds? Maybe 10 to 15 minutes. I do highly recommend, as I put on the handle of this one, it's called the Spider Tool Holster. And what it allows you to carry I think it's designed for like a DeWalt drill, cordless drill, but allows you to hang it right on your belt and have the camera right on your hip with you all the time. Can't think. Sean Troxel, you guys know that name. He's up there, Maryland, I think.
Yeah, he's on this.
And he's the one that recommended it to me. And ever since I've been recommending it to every home inspection class I've been teaching. The other question I've been asking is like John Cheney, who's a home inspector out of Champaign, Illinois. John and his 3 home inspectors that work for him are doing 10 inspections a week each, and they do infrared on every home inspection they do. And I said, John, what percentage of home inspections would you say you find thermal anomalies worthy of going into the report? And he thought about it for a minute and he said, probably about 20%. Now I've heard that back from a dozen people, about 20% of the time. And I said, okay, the other 80%, do you put any thermal images, even though you don't find a thermal problem, if you will, a thermal anomaly, do you put thermal images in those reports? And he said, everyone gets a thermal image of the electrical panel, thermal image of the ovens, ranges, refrigerators, freezers. And if there's a question a month from now and they say, my refrigerator, freezer quit, if you turn to page 17 of your home inspection report, you'll see the thermal image of the freezer, and it was plenty cold enough while I was there, or the refrigerator. So the CYA, the cover your butt that you can do with an infrared, is another good reason to incorporate infrared to what you do.
Cool.
Any other questions?
Yeah, you mentioned a map that shows where your certified inspectors are.
Yeah, let me, I'll share my screen again real quick, see if I can do this real fast. All right, so you're seeing IR and aerial inspections, and then IR training and ITC, and then infrared cameras. If you scroll down a little bit, click on the CRT logo. It takes you into the new CRT class schedule. And if you scroll, there's me teaching my bald head. You scroll down. Oh, you gotta be shitting me. Excuse my French.
Well, there it is. Click here for locator. Yeah.
Why don't I see it? You see it and I don't. There's
see it now.
class.
I see it now.
Okay. There's class schedule.
I put the link in the chat, Bill. It's on the infrared training page. I think if you click training, go down to the middle of the page.
Ah, there you are. Yep.
Yeah.
Click here for the CRT grad locator. Thank you. And then give me a zip code. Any zip code.
22042.
23910.
One at a time.
22042.
22042. Search. If it works right, there you go. Marietta Inspections, Washington, D.C., Patrick O'Connor, Capitol Hill Home Inspections, Pillar to Post, Red Carpet, Home View. Whether you're a one-man show or a 10-person multi-inspector, you only get one listing per company. So the same exposure for a one-man show versus, multi-inspectors. So, and the reason this is even here is because we were starting to get calls, hey, do you know a home inspector in San Diego, California that does infrared? I got to go back. My memory is not what it used to be. That's for sure. So that's why I came up with the idea to have the CRT grad locator on our website. So, we can just refer them to this page. And I just wrote an article. If you guys get the Working RE magazine, Working Real Estate. There's a
Cool.
nice article in there that I wrote about infrared. And we promote the CRT grad locator. We promote home inspections. So I wouldn't buy another house without one. I'll tell you that. The stuff
Cool.
I've learned. Any other questions? Well,
Well,
one last chance for me, again. November 21st, Monday is the Black Friday, Cyber Week, whatever you want to call it, sale. Like the $2,500 M30 complete system is $500 off. You're not going to see any links on anybody's web pages because it's blacked out. But if I'm talking directly with a group like I am right now, it's not open to the public. It's a closed meeting. I can talk about it. But we are already taking pre-orders. So instead of $2,500 for a complete system, you're talking about $2,000, $500 off. So that's a hell of a camera. And they got the little pocket too, about the size of a cell phone. It's $480 instead of $600. All kinds of good deals and good stuff going on. So there's, my phone number, part of my screen right there. 800-221-0163. If I can help with anything, don't hesitate to call. And I look forward to getting back out there to New England and working with you guys, Nova ASHI, and doing another CRT class, maybe in person.
all right. Well, thank you, Bill. We really appreciate it and the enlightenment, and it's valuable information.
Thank you, guys.
Thank you, Bill.
All right. I will log off and go have my dinner now. Thanks.